Hello, everyone. Today, I will introduce our work, GeoAgent, learning to geolocate everywhere with reinforced geographic characteristics. In this paper, we focus on image geolocation, which aims to infer where an image was taken based only on its visual content. Our goal is not only to predict a location, but also to make the model reason, like a human geolocation player, using clues such as signs, buildings, roads, vegetation, and languages. Our motivation comes from several limitations in existing methods. Traditional geolocation methods usually formulate the task as classification or retrieval, but their reasoning process is not transparent. Recent vision language models can provide explanations, but many of them rely on AI-generated chain-of-thought data, which may not reflect real human reasoning. Also, existing reinforcement learning methods often use exact text matching as the reward. However, this is not suitable for geography, because different names or descriptions can refer to the same place. Therefore, we want to build a model that can reason more naturally, predict locations more accurately, and learn with rewards that better match geographic characteristics. To achieve this, we first construct a new dataset called GeoSeek. GeoSeek has three components. The first one is GeoSeek Co-T, which contains 10,000 high-quality reasoning examples annotated by geography experts and experienced geolocation players. The second one is GeoSeek Lock, which contains 20,000 globally distributed street view images for reinforcement learning. The third one is GeoSeek Val, a validation benchmark with 3,000 samples. It includes locatability scores and labels for geographic elements such as traffic signs, buildings, languages, natural landscapes, and man-made structures. Compared with previous datasets, GeoSeek provides more human-like reasoning, finer-grained location labels, and a more balanced sampling strategy. Our method follows a two-stage training pipeline. First, we use GeoSeek Co-T for supervised fine-tuning. This stage gives the model a cold start and teaches it how to organize reasoning into three levels: country identification, regional guess, and precise localization. Then, we apply GRPO-based reinforcement learning on GeoSeek Lock. During this stage, we do not simply reward exact text matches. Instead, we design geography-aware rewards to guide the model toward correct and consistent geographic reasoning. In this way, the model first learns a human-like reasoning format and then improves its localization ability through reinforcement learning. The key part of our method is the reward design. We propose a geosimilarity reward, which contains two components. The first is spatial similarity. It measures the physical distance between the predicted location and the ground truth. If the prediction is closer to the correct location, the model receives a higher reward. The second is semantic similarity. It measures whether the predicted address is semantically close to the ground truth, even if the wording is different. This helps handle aliases, abbreviations, translations, and different valid place descriptions. In addition, we introduce a consistency reward. A separate consistency agent checks whether the reasoning process can support the final answer. Together, these rewards encourage GeoAgent to produce answers that are not only accurate, but also logically consistent. We evaluate GeoAgent on both public benchmarks and our GeoSeek Val benchmark. On IM2 GPS3K, GeoAgent achieves strong performance, especially at the country and region levels. On GeoSeek Val, GeoAgent also outperforms general vision language models and previous geolocation-specific models. For example, GeoAgent reaches 60.37% country-level accuracy and a GeoScore of 3,314.1. These results show that our method improves geolocation performance across multiple geographic granularities. We also observe that GeoAgent performs better on images with higher locatability, which suggests that its reasoning process is closer to how humans use visual geographic clues. We further conduct ablation studies to understand the contribution of each component. First, the supervised fine-tuning stage is very important. It improves the base model's country-level accuracy from 11.13% to 47.12% on GeoSeek Val, showing the value of human annotated reasoning data. Second, both spatial similarity and semantic similarity improve the model's geolocation ability. Spatial similarity provides a direct distance-based signal, while semantic similarity makes the reward more robust to different place names. Third, the consistency reward helps the model generate more complete and reliable reasoning. When all components are combined, GeoAgent achieves the best overall performance. This slide shows a qualitative comparison between GeoAgent and other models. For the same image, GeoAgent correctly predicts Santiago, Chile, while other models predict locations such as Argentina, Uruguay, Peru, or Valparaiso. The reason is that GeoAgent follows a clearer hierarchical reasoning process. It first identifies country-level evidence, then analyzes regional clues, and finally narrows down the precise location. Other models may over-focus on a single clue or generate explanations that are inconsistent with their final answers. This case demonstrates that GeoAgent is not only more accurate, but also more interpretable and more aligned with human geolocation reasoning. To conclude, our work makes three main contributions. First, we introduce GeoSeek, a new geolocation dataset with human expert and player chain of thought annotations. Second, we propose a geography-aware reinforcement learning strategy, including spatial similarity, semantic similarity, and consistency rewards. Third, we develop GeoAgent, which achieves strong performance while producing more human-like and consistent reasoning. Overall, our work shows that image geolocation should not be treated as simple label matching. Instead, it should be viewed as an evidence-based geographic reasoning task. Thank you.